Welcome to On Chemistry. Always try to do your best. Now, let us see about 100 conversion in organic chemistry. We are seeing it as episodes. This is the episode number 96. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The starting metal is epoxide which contains trans-methyl group and one methoxy group. We are using lithium phenyl phosphide and methyl iodide. They ask you to find the product. The product can be alkene. The alkene can be cis or trans or the new methoxy substitution in the cis and trans version. So basically the configuration of alkene. So from the reactant to product you might guess one naming reaction is involved since phosphine and oxygen is there. Then the ring opening definitely occurs there. The answer is A. Let us see how. In the starting metal you are having epoxide, you are using lithium. Lithium can abstract the electron from oxygen and weaken the oxygen bond. Now the ring has to open because it's a strained system as well as charged system. So you are adding phosphine in the next step. What really happens is phosphine can attack either side. The phosphine will attack in the less hindered side. So the ring is open. Both can be on transposition. Now you have the possibility of Wittig reaction. So what you have to do, you have to rotate the OLA bond. Once you rotate the OLA bond, the methyl will go above and the ethoxide go below. So both will be inverted because of the rotation. So O and phosphine on the same side. Next step you are using the methyl iodide. Methyl iodide really attack the phosphine and you have cation at phosphine and you have negative charged oxygen because lithium is the electropositive metal. So you have the possibility of Wittig reaction. The phosphine oxide is eliminated. It's an intramolecular Wittig reaction. So you have the E product there. So the answer is clearly A. Here you have to learn two important things. The epoxide ring opening. Epoxide is a strained system, it will open, but the attacking nucleophile attack on the less hindered side. Second thing is Wittig reaction. If you have phosphine and O- in the system, you might think of Wittig reaction. Here stereochemistry retained there throughout the reaction. That's why you got the E alkene there. Then the question number 2. The starting metal is phenol and aldehyde and amine. You are heating it. They ask you to find the product. The product is mostly N attack on the ring, whether attack in the ortho position or in the para position, or alcohol get oxidized to aldehyde, which is again the amine in ortho or para. So from the reactant to product you might guess position of amine and fate of OH is important here. The answer is A. Let us see how. The starting metal you are having aldehyde and you are having amine. So what really happens is the imine formation will be there. So it possesses the positive charge and nitrogen can attack the phenyl ring. Here nitrogen can attack ortho and para position, but the possibilities are restrained by hydrogen bonding. So what really happens is hydrogen can play between those atoms. It is called intramolecular hydrogen bonding, which stabilizes the ortho form. Even though the possibility of both are there, you have the major product as ortho form. So orthoamine formation will be there. The reaction technically called as Mannich reaction. Basically you are creating new CC bond. Here you have to learn two important things. One is selectivity of amine in the benzene ring. Here ortho attack is very favorable because of the 6-member transition state. Second thing is Mannich reaction. Mannich reaction is an important concept because you are introducing methylamine to the system. What really happens is new CC bond formation. Then the question number 3. The starting metal is phenol. In para position you have long chain amine with dimethyl attachment. Next step you are adding methyl iodide and silver oxide and you are heating. Then you are using KMnO4. So the product can be on 4 types, whether the alcohol converted into ether which is OCH3 or the para form. So what really happened to para form? Then the next reaction center is para form. Para form get oxidized or not. oxidase to the chain, or oxidase just to the carbon. From the reactant to product, you might guess the role of functional group versus reagent is important here, the competition. The answer is D. Let us see how. The starting metal you are having alcohol, you are using the methyl iodide. So what really happens is methylation occur. But there is a two possibility of methylation. The nitrogen also get methylated, oxygen also get methylated. Nitrogen become quaternary ammonium salt, alcohol become ether there. So two functional group conversion. Next step you are using heat with silver oxide. So what really happens is it's a Hofmann elimination. So the nitrogen group, which is quaternary ammonium salt eliminated, you have alkene formation. So new alkene formation. Then the next step you are using permanganate. Permanganate is a strong oxidizing agent. It removes the CH2 or it removes the side chain from the system. It directly converts anything after carbon become carboxylic acid. It's a vigorous oxidizing agent. So the answer is clearly D. Here you have to learn two important things. One is Hofmann elimination. Hofmann elimination always leads to the alkene in presence of heat and silver oxide. Second thing is permanganate. Permanganate is a vigorous oxidizing agent. It removes anything from the side converted into carboxylic acid. Then the question number 4. The starting metal is alkyne with linear chain. It's a symmetrical system. You are using sodium and liquid ammonia and hydrolysis. They ask you to find the product. The product can be terminal alkene or the symmetrical alkene or the terminal alkyne or the cis middle alkene. So basically the double bond and pi orbital configuration. From the reactant to product you might guess reduction definitely possibility and double bond configuration is important. The answer is C. Let us see how. The starting metal is alkyne. You are using sodium in liquid ammonia. Sodium is the ultrapositive metal. It donates the electron. So what really happens is donation of electron to double bond leads to anion and radical. It's a radical anion. Here cis and trans both forms are possible. But if you are thermodynamically speaking, always trans is major because it avoids the steric crowding. So the crowding of nearby group is avoided. So trans is the major one. So the anion is there. Next step you are using H plus, which is hydrolysis kind of situation. So H plus add to the anion, you having hydrogen bond there. You are having carbon hydrogen bond. Next step radical is there. Again sodium can donate the electron to the radical. So radical gain the electron, it becomes the anion. So you are adding H plus again. So you are getting the trans alkene, which is a symmetrical alkene, which is answer C. Here you have to learn two important things. Sodium and liquid ammonia is the electron donor. It's electronic reduction. So the electron is donated to the system twice. Second thing is the intermediate. Here the intermediate is radical anion. Next step radical. So both are possible in this situation. Then the question number 5. The starting metal is linear chain with 3 alkenes. You are using the ozone and hydrolysis. They ask you to find the product. The side products can be acetone and 2-formaldehyde. So the 4 possibilities are given. What really happened to alkene? Whether alkene converted to ketone or the aldehyde, or selectively 1 or 2 alkene bonds are oxidized, ozonized. So the ozonolysis possibility is discussed here. So from the reactant to product you might guess ozonolysis occurred at the alkene. The answer is B. Let us see how. The starting metal you are having many alkene. Here I given the color for easy product identification. You are doing the ozonolysis with hydrolysis. So what really happening? Ozonolysis convert the CC bond to 2CO bond. The below the box is showing you are having alkene. You are just inserting oxygen between the alkene. So you have dihedron there. The same situation occur with every alkene in the bond. So the top alkene become ketone and aldehyde, which is blue color, and the middle one, it also become formaldehyde and aldehyde, and the below green one become also formaldehyde and ketone. So there are 2 aldehyde formation, 1 ketone formation, and the possible product is B here. Here you have to learn only one important thing, ozonolysis. Ozonolysis is a simple thing, but it always confuses you to the final product. If ozonolysis occur at the middle carbon, it's ketone. If ozonolysis happen at terminal alkene, it is aldehyde. As simple as that. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.